Hello and welcome. On the bench today I have a Bakon BK-999N T245 soldering station. On this video we're gonna assemble it, turn it on, test it, and then check for the usual suspects. The voltage leakage, current leakage, whether it's properly grounded, and whether the temperature reported by the display is accurate. We're gonna test it on ground planes, we're gonna make sure that it works as it should. Then we're gonna take a look inside, and then I think I'm gonna use it for probably a few weeks by myself for my work, and during those weeks I will make sure that it works and I'll come up with an opinion at the end. I'm comparing with my own genuine JBC soldering station, bearing in mind that I believe that the JBC is like 5 times more expensive than this. I'll need to find out what's the price, the selling price of this, but we'll have to keep that in mind, of course. I have tested a T245 station on this channel before. It was the Aixun T3A. It didn't go very well, and since then I've been wondering whether there's something in between the Aixun and the JBC, which is very much, I would say, overpriced. So my hope is that the BK-999N is a good station at a reasonable price that performs well. Now, to be clear, I've received this station for free from Bakon, but I've been very clear with them. This is going to be an unbiased review. They have no control of what I'm going to say, and my final opinion is going to be final. Now, enough me talking, let's open the box and see what's inside. The BK-999 is based on a linear transformer, and that was one of the reasons for me to choose this station on the catalog, because I understand it's going to be unlikely that this is going to have any voltage leak and current leakage at the tip of the soldering iron. So this is quite heavy, but I don't mind. Also, what I like about this is the cradle detached from the station. It's something I've been missing from my Aixun. My JBC comes all together in one bit, and I like the idea that I don't need the transformer, the power supply on my desk. That being said, the cradle feels a bit budget, let me put it that way. I think this part is made of plastic, and I don't know how it's going to work with very hot tips. We'll check in a minute. It's definitely not heavy enough to be able to swap a soldering tip using just one hand. You'll have to hold the cradle on the desk. And there is a blue silicone cable here which connects the cradle to the station to enable the sleep function. The handle is basically identical to my genuine JBC. The only thing missing is the little seal gasket here at the top. I believe it's missing from any non-genuine JBC station. I don't really know why. Now, this station is 230 volts only. If you want the 110, you need to order the 110 version. And one thing I really don't like is that it doesn't come with an IC socket at the back. So the mains cable goes directly into the station, and in this case the station comes with an European plug. I was aware of that, and I will ask Bakon whether they're happy for the users to remove this and install a UK plug if you live in the UK. This VGA style connector is not for a monitor, unfortunately, but it's for an external sensor, which is optional, so I don't have it here. And I understand that the station can check the continuity of voltage leak and grounding automatically at the press of a button. Now, one very cool feature is that the front panel here is detachable. It's attached to this connector here, and it doesn't come, unfortunately, with the extension wire, but this could be extended. I guess you can make your own extension, and you can have it wherever you want. There's also an optional to have it hung here at the front of the station. Again, it doesn't come with it, so I'm sorry, because I thought it would be a good idea. So this can stay on a shelf and the front panel is facing me instead of facing up in the air. But I like the flexibility that you can actually make your own extension and have the display wherever you want. Now, when Bakon got in touch with me, I had a look online, and it looks like Bakon are manufacturing tools for manufacturing facilities. So I have very high expectations for their tools. Now, when I was discussing this product review with Bakon, I made very clear that I wouldn't be happy to find any soldering station which had improper grounding on the tip, voltage leakage, and current leakage. And Bakon seems to be very comfortable in sending me these products. They are super happy for me to do all my tests, and they said that I won't be disappointed. So before we even begin, let's check that the tip is properly grounded. And it is. These probes are pretty much crap. They read 1 ohm by itself, so that is totally fine. So I'd be ready to turn on the station, but unfortunately none of my Schuko adapters here are passing the ground properly. They're not passing it at all. So first thing first, I'll have to replace the plug, which I understand is not the first thing you want to do on something that you're purchasing. But anyways, let's do that. Alright, the station is on. First thing first, let's disable the buzzer. I'd say it's a good idea. To get into the menu is this button here, and I think it's System. There we go, and we disabled it. Now, one thing I not particularly like with this menu is it goes back to the standard operation after 3 seconds, but it's alright. It's a soldering station, you don't need to go into the menu very often. Now, I had a look at the manual, it's reasonably clear. There are not many options in the menu, but again, it's a soldering station. I think I've seen recently a soldering station with AI intelligence. It's a soldering station, you don't need AI in a soldering station. It just makes something hot, that's it. But something I've noticed is obviously we got the language, and then we got the standby delay, which can be configurable between 10 seconds, 0 seconds actually, or 2 seconds, and the maximum of 99. I don't know if it can be disabled. No, it's a maximum of 99 seconds. That to me is not enough. I think on my JBC I have 15 minutes. Because I don't particularly like the tip going up and down in temperature. I think it stresses the tip. So just for a few minutes, I'd rather have the tip staying at 350 degrees, and then I keep using it rather than the tip going up and down between the standby temperature. It's not 0, which can be set. I think it's set to 180. But anyways, you have 99 seconds of delay maximum and a minimum of 2 seconds. We have the usual options: temporal units, language, password. And then into the tools section, we have, keep moving this, otherwise it goes back. We have a temperature offset basically, and we have a maximum and minimum temperature that the user can select. Again, these are designed for manufacturing facilities, so it could be useful, might not be useful for you, for example. That's the standby temperature, the temperature when the unit is in standby. And these V and R warning, it's, as I said, there's a little button here, MV and OM symbol. It's for this little optional tool where you basically plug the tip on the tool, you push this button, and the unit is telling you whether you have voltage leakage and whether the tip is properly grounded. We have a reset facility and handle type, which for whatever reason is set to 210 by mistake. This can do 245 and 210. So let's confirm 245. Yes. Confirm again. Yes. Is it burning my tip? Yes. No. The tip is smoking. Right, okay, so I expressively ordered this with 245. It took actually quite some time to have it 245. So it's a bit disappointing that I found it with 210. But anyways, there's nothing else in the menu. As I said, it's very, very simple. To set the temperature, that's it, these 2 buttons, and there's nothing really else. And I'm really happy with this. You don't need anything more in a soldering station. You don't need a color display. You don't need AI. You don't need anything else. Now, I don't think my thermometer is super accurate, but it can give us an idea. So let's see what it reads with the unit set to 350. This is the tip that I found in the box, and later on I'm going to do all my tests with the JBC genuine tips. I just wanted to start with this, just in case something nasty happened. Well, it's reading 340, so I'm pretty happy with that for 350. And one thing I've noticed, even with my JBC, the temperature slightly changes between tips. So, I don't, as long as it's not 100 degrees off, I think it's totally fine. But yeah, this is a very good start. Now, next step would be to check for voltage leak and current leak. That's very important to me. I got my multimeter connected to ground. You can see from here that this is still grounded. Now let's check what I'm reading as DC voltage on the tip. I'm reading 0. That's absolutely amazing. No little something, 0. And what we get in AC, I guess, is going to be exactly the same. Yeah, that is totally fine. And I got the multimeter in current mode. This is DC. Let's see what we're reading. We're reading absolutely 0. And let's go to AC. And we also have absolutely nothing. Now, let me check. I think I have another multimeter which is reading milliamps. And I'm reading 0.030 milliamps. So basically that is 0 to me in DC. Let's change to AC. We have 0.2 milliamps. So that is 0 to me. Fantastic. I am super impressed so far. It's fair enough, it's a linear transformer. I was kind of expecting it. And I'm so happy to see this kind of readings with the Bakon. Just to be clear, my acceptable voltage leak and current leak of any soldering station is 0. I want to read 0 everything. Everything needs to be grounded, and I don't want to see any voltage, any leakage of voltage or current. So this is a very good start. Now let me do my favorite test. I have a speaker which is wired to ground on one end. On the other end, I'm going to touch the tip of the soldering iron while it's heating up. So any current leakage will be heard from the speaker. And I'm really happy to hear nothing at all coming from the speaker. So this is absolutely fantastic. No voltage, ADSIP, no leakage, and proper grounding. Amazing. Now, what about soldering on grounded PCBs? And if you don't know what I'm talking about, I recommend you go and watch this video where I discovered that my Aixun T3A was massively misbehaving when ground was in the way. Ground can be in the way. One example for all is your preheater. Your preheater is grounded, you rest in the PCB on the preheater, and you're automatically grounding it because the PCB is touching the preheater. So this is a CRT neckboard, and it's grounded here. This little black wire is connected to ground, and I'm grounding these heatsink here. So let's try and solder around these pins, which for whatever reason were the ones particularly upsetting the T3A. Let's see if we see anything. Do we see anything weird with the power? And then we're measuring, well, 360. So yeah, so far so good. I see the power going up a little bit. I guess it's just to keep the temperature at the right time, at the right temperature. Yeah, 360. There's nothing is trying to hide the actual temperature. Yeah, shut up, multimisa. But I don't see anything weird happening. Yeah, 340. So yeah, of course the temperature is oscillating a bit between around the set temperature. 350. Yeah, it seems totally fine. So it looks like, at least with this inconclusive test, I can't replicate, I can't see anything weird. Now, obviously, of course, I will use the soldering iron on my actual work, which happens to be on grounded PCBs, or at least the PCBs are on a preheater, which is grounded. So they tend to be grounded. And that's when I discovered that the T3A was massively misbehaving. And I'll report to you whether I observe anything wrong when soldering on those PCBs. Now, let's talk about this Cradle for a moment, because I'm not sure I'm impressed by this thing. So I was looking into that, and I think I found two major, I would say, problems with this Cradle. Number one, the front part, the blue one, is metal. Is it metal? Yes. The back part is made of plastic. Now I see these holes here, and I thought, well, maybe it's heat-resistant plastic, and you can store your tips in there. But is it heat resistant? It's not. I don't know how much you can see that, but it's clearly not heat resistant. So I don't really understand how this works. Now, obviously, I can store my tip in here. I can clean it here. It's fine, even though the bottom is made of plastic. So eventually, you're going to damage the plastic. The sponge is going to go in here. So you need to be careful, because if you're touching the side here, you're going to damage the plastic. But most importantly is, how do you remove the tips from the handle with this thing? Because I'd assume maybe it's this, but if I do this, then the tip will fall into the plastic. So the plastic will melt. I don't see any other way. Yeah. So what do I do now? I can't touch it because it's scorching hot. But I can't store it anywhere because this is made of plastic. So basically there's no... Oh, thanks. So basically there's no storage for tips on this Cradle, which I think is a big deal, because the main advantage of a 245 is that you can exchange tips. You can use multiple tips. I do that all the time. I have 3 favorite tips I'm using all the time, and the JBC, by the way, is heavy enough so that I can do that with single-handed. Now this one needs a hand, fair enough, but there's no storage. I can't store anything here, and I will need a separate tool for storing, and most importantly for removing the tips, because I can't remove, yes, I could remove the tip here, but then I don't know what to do with it. As a quick comparison, this is the Aixun Cradle. I bought it because I'm planning to build an act solder, so watch the space. And with this one, obviously, I have facilities to remove the tips, and I'm hoping that the material here is heat resistant. Yeah, I can feel it's not getting damaged by heat. So yeah, I'm sorry, but this is really, I don't think this is fit for purpose. So just bear that in mind. We'll get in touch with Bakon and maybe report this one. Maybe they want to think of a different design for this. But if you get the unit as it is right now, you get a Cradle, which is not very useful. And that's not all. That's not the only downside of this Cradle. This is the blue wire for the sleep function. Unfortunately, it needs to be wired to the Cradle. It's not the end of the world, but it plugs in here. There you go. Now it plugs in here, and do you see anything wrong with it? I mean, I've got the sponge in there. Let's put some water on it. So how am I supposed to use a sponge? Is the frame is made of plastic, so I need to pay attention at it. And then I have this wire in the way. Yes, I mean, I can do this, but yeah, I think I burned the connector already, because this is silicone. Oh, is it? No, it's not. Okay, this looks like silicone. Oh no, it's burning. Right, so this is not even made of silicone. So no, I'm sorry, Bakon, but this is another, it's unusable. I tend not to use the sponge on my soldering station, but that's not the point. It's basically unusable, I'm sorry. I mean, I can try and route it differently. I can route it from here. But as you can see, it's in the way. It's in the way. It would be a bit less in the way if you're left-handed, then you can come from this direction. Let me check the actual handle wire. That has to be silicone. Okay, yes, this is silicone. Okay, at least this one. But as it stands, the Cradle is basically unusable, especially with this wire in the way. Well, at least the standby feature is working. Now let's talk about power. What is the power capabilities of the station? Now the manual says that this station can deliver 60 watts in 210 soldering tip, but with the 245 it can go up to 110 watts. And my JBC soldering station is rated 135 watts, so we can do some comparison. Now let me say something about power first. I don't consider the power of a soldering station for general purpose use so important. And the reason is that you're gonna see this station delivering full power into your tip only on two scenarios. The first scenario is when you turn it on. Fair enough, if your soldering station can deliver 200 watts, well, that's gonna be 200 watts into the tip when you switch it on until it's reached temperature. And if your station can do 200 watts, well, that means that that station can reach the set temperature faster than another station that can only deliver 100 watts. The second scenario is when you're using a huge tip on soldering on copper or something like that. At that point, yes, I can totally imagine that any of the stations can deliver 100% of their power into the soldering tip. But let's be honest, the average user doesn't do that. And I can tell you that with this tip here, it's a genuine JBC. I don't think I've ever seen my JBC station going to 100% when soldering, only when I turn it on. So personally, I think that something around 100 or 150 watts is totally fine. You don't need to look for 200, 300 or more unless you have some special needs. I then tried calculating the actual power delivered to the tips by both stations using my watt meter. The Bakon would draw 115 watts from mains, while the JBC would draw 188. I feel that the result was inconclusive though, mostly because I do not know how much of that power is actually delivered to the tip and how much is lost by the transformer. But I'll do a more accurate test later on and I'll come up with a better number. For now, let's move on and do some more cool tests. We're gonna do the coin test, where we're gonna try and melt the solder on these 5 pence coin here, but I also have a 42 by 42 copper shim. This is 3mm thick, so it's quite a challenge to melt this solder on top. Now obviously this is not representative of what you would normally do with a station while you're soldering, but it can definitely highlight the differences between these two stations, and most importantly, I like doing it, so why not? At the same time, we'll keep an eye on the watt meter to have a look at what kind of wattage is being delivered to the tips. I'll do a little montage so you can see both stations running simultaneously at the same time. Both stations are set so they measure the same temperature. Ignore the different display temperature, I didn't apply an offset in the menus. Solder on the coin doesn't take long to melt, and both stations end up completing the task more or less in the same time. The large copper square is a bigger challenge to overcome, but once again, both stations end up even, managing to melt the solder more or less at the same time. If we want to be fussy, the JBC has a slight advantage on both tests. I then compare the time it takes for the stations to melt some solder from cold. Both stations appear to take more or less the same time, but the Bakon is faster in booting, so I edited the following segment where I compare just the actual heating time, and the JBC is more than twice as fast. The Bakon is still pretty fast, of course, but this seems to highlight a much higher power delivered by the JBC station. As I said, these won't really affect actual soldering, but you'll notice the extra time when swapping tips. A few weeks have passed and I've been using the BK-999N as my main soldering station along with my JBC one, and I think I've managed to develop a good opinion about this machine. Now before we get to that, it's time to take a look inside this machine and see how it's made. So let's open it up. Warranty seal. Alright, we are in. It's a very simple design, but I think I like it. We've got mains coming here through the mains wire. It's going to a small PCB here on the right hand side, and then mains going through the switch here at the front and back to the little board and into those red wires which are taking mains into the power supply, the transformer actually. I think I mentioned at the beginning this is a linear transformer, no switching mode power supply. I have another station from Bakon which I'm going to review on another video which features a switching mode power supply. I'm really curious to see what they've done with that. Mains is going into the transformer and it's coming out through these pretty chunky wires, I have to say. These are AWG22 to this little board here, and everything is using connectors. Nothing is soldered besides earth, ground, which is going to the metal frame of the transformer itself to ground it. Here on the left hand side we have the output going to the handle here at the front, and this yellow cable is going to the sleep connector here at the back. Now everything is using connector, so it's pretty serviceable, and I was looking for a microcontroller on this board and I couldn't find any, so I assume that the microcontroller is in the display. That's kind of an interesting design. I think this little PCB here is just a power delivery board. It only has some ICs to deliver power from the transformer to the handle, to the tip, based on what the microcontroller says, which I believe once again is inside the LCD. I guess this makes the station quite serviceable, because if something happens to this board, you don't have to replace the whole thing with a microcontroller. And I guess if something fails in a soldering station, it's probably where power is involved, which would be everything on this board basically. Now I feel the construction is quite good. Just a couple of things. I don't feel I'm too qualified for that, but if this had been my project, these two red wires are mains going into the transformer, while these are low voltages. Again, these are pretty chunky cables. I would have probably used an extra sleeve around the mains wires just to, add an extra layer of safety. And also I see that the wires going to the handle at this connector here, they're all pushed around the transformer casing. Again, I don't think the transformer is getting to silly temperatures, but maybe it's not the best to see. But anyways, I see everything is being insulated here with some glue, and yeah, it's probably not the end of the world. This is low voltage, nothing is going to happen, but probably something I'd like to mention. But all in all, I feel it's a nice construction, nice design. I don't see anything nasty. Everything is grounded. I really like this dual board separation with power on this board and all the electronics and the control on the other one. Now, let me try and remove this board. We'll take a look. Then I guess we'll open the LCD and we'll see what's inside. C'è un modo di tirarla via questa. Oh sì. Ah, wow. Oh, wow. 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 Well, I have to say I'm super impressed. I went to remove the connector here, the screws of the connector, because I thought the whole thing came out. But no, the board is plugged into these. It's a VGA connector. It's nothing to do with video. They just reused a 15-pin connector, and it just comes out like this. This is just amazing from a serviceability point of view. The board fails, they just pull it out, besides the ground wire for obvious reasons, and just put another one back in. So. I mean, I'm hoping that you don't need to do it, but this is amazing. In 2025, where everything is glued together and attached together in a way which is impossible to repair, this comes out like this. Well, the board is pretty simple. There is a bridge rectifier here, and there are two linear voltage regulator, 5 volts and -5 volts, which I guess are for the electronics going to the display where the microcontroller should be. And then we have two MOSFETs. Apparently these are MDP-1991. They are N-channel MOSFETs, and that's it. Then we have some capacitors and some passive components here at the back. Now, I like that this is called the 999 Power, and as I said, as I thought, this is the power board, the power distribution board. It looks well made. I'm not an expert when it comes to this thing, but these MOSFETs are rated 100 volts, 120 amps, and this is kind of a low power station, so I don't know, it looks like a pretty chunky design for the power the station is dealing with. And also I like this little gap in between this section and this section, because I guess this section is the power section going to the handle, and this section is the power section going to the microcontroller. Now, when it comes to power MOSFETs, they can fail. When they fail, they might fail spectacularly, even though, again, there's no very high voltages coming from the transformer. So I guess the reason that you have a gap is to prevent any damage to go to the microcontroller. So once again, you open the box, you replaced it, you pull this out, you just desolder and resolder the earth wire, and you're good to go. And I don't know, in 2025, this type of serviceability, I wasn't expecting it. Everything is nice and labeled, nothing so far has been erased, which is quite nice. I can see that from the main transformer we have 8 volts AC, which I guess is used to generate the plus and minus 5 volts for the microcontroller. And then we have 14 volts, which I guess is used for the handle and for the actual soldering tip. Well, so far I have to say I am pretty impressed. Let's open the display and see what's inside. And the board is out, and yes, it's called the MCU, the microcontroller unit. On this side we have just the LCD, some buttons. And on this side we have the microcontroller, which is an Atmel Mega 32A. It's an 8-bit MCU, 32 kilobytes of flash memory, 2 kilobytes of SRAM, and 1 kilobyte EEPROM. It's an Arduino, basically. It hasn't been erased, it's another good thing. And then we have two operation amplifiers here. And that's it. It is very simple. I really like the idea that the microcontroller is separate from the power board, so in case anything happens, the serviceability is the best ever. The only thing which is missing from this soldering station is an easy way to update it, like a USB port. I'm sure that you can do it through the VGA connector, but it's not a VGA cable and a monitor to update it, of course. That being said, it's a soldering station. You have a soldering tip, it gets hot and it melts solder. If the station has been properly built, you don't really need a firmware update. Definitely you don't need many firmware updates, so it's not the end of the world. It seems to be working anyway, so it's not the end of the world. Well, this is it. I was totally not expecting such a nice building quality in terms of having two different boards and so easy to disassemble, so easy to service. But that's it. Let me put this back together. But before we close it up and we come to the final conclusions, I'd like to do a final test. Now, before closing the soldering station, I'd like to check the power delivered to the soldering tip in a more precise way. This is the tip I'm going to use. It's a genuine JBC, and it reads about 3 ohms, 3.1. Now, I think these tips have rated 2.5 ohms, so I'm not sure whether the internal resistance of the heater changes with temperature, but for now, let's assume 3.1 ohms. And now I'm going to measure the actual voltage going to the tip, and we'll do a little bit of math and see what kind of power is being delivered to the tip. As soon as I power up the station, the tip is going to be powered 100% for several seconds while it reaches temperature, so we should have a clear reading on the oscilloscope. Power up in 3, 2, 1, go. There we go, we see very clearly the waveform. And now the tip has reached temperature, there is nothing going to the tip, and there's every now and then some waveforms going to the tip. Now, first thing first, I see that this soldering station is using AC to power the tip. It makes totally sense, and there must be some sort of 0 volt detection, so the microcontroller knows where the voltage is crossing 0 volts, basically. So the tip is either receiving a positive wave or a negative wave. You know, from a power perspective, it doesn't change anything. Now the oscilloscope is measuring 51.6 volts peak to peak, and considering 3.0 ohms as the heater resistance inside the tip, with a little bit of math, I end up with a maximum power of 107 watts. The bottom line is that this power supply is providing 51.6 volts AC peak to peak, and then it depends on the resistance of the heater inside the tip. With this JBC tip and measured when it's cold, I don't know what happens when it's hot, that's the wattage that the tip is getting, which is pretty impressive, and also it matches what the manual of the station says of 110 watts. Now you'll see that the power delivery is not constant even when the tip is cold, so there is no reason for the microcontroller to pause the heating. My understanding, but I'm not entirely sure, so please do leave a comment down below if I'm saying rubbish here, is that the heater will have to be stopped when the temperature is probed, because I think the thermocouple and the heater, they're sharing the same circuit, so in order for the microcontroller to probe the temperature, the heating has to be momentarily stopped. And I believe that's exactly what happens on screen right now. But yeah, I'm glad I did this measurement, so at least we know exactly what kind of power the station is able to deliver to the tip. Now I think it's time to close the station for good, and I'll come up with my own conclusions. Do I recommend the station, or is it better to look elsewhere? So let's begin with my few weeks experience using the 999N as my primary soldering station. How did it go? Well, it went well, it just worked. I didn't experience any issues whatsoever. As I said, I used this station for a number of weeks as my main soldering station on grounded PCBs, by the way, and I didn't experience any issues whatsoever. Compared to my JBC, which is clearly a bit more powerful than this, honestly, it didn't change anything. I'm using the same JBC tips between the two, and it worked exactly as my JBC. The only difference that I could find is just that when I change the tip, the JBC takes less time to get to temperature. This is a bit less powerful, it takes a few more seconds. Not the end of the world. So yes, I do like the station, it works totally fine. There is no voltage at the tip is properly grounded, no voltage leak, no current leak, and it works totally fine. But there is still something I don't like about the soldering station. Number one, as I mentioned multiple times, the stand. The stand, unfortunately, as I mentioned, I would say, is not fit for purpose. I'm sorry, Bakon, but this stand could have been so much better with so very little. Half of it is made of non-heat resistant plastic. There is no facility to remove and store tips, so that unfortunately is it's just a big no-no. If you're getting the station, either you live with it, or I would recommend you replace the stand with something better, or you can get like a silicone sleeve to remove the tips, and you can just make a little storage solution as I did here with a block of wood and drilling some holes in it. It's not the end of the world, it's not ideal, I'm just telling you so you can make your own decision. Another thing I'd like to mention is that compared to my genuine JBC handle, the handle here offers a little bit extra friction when swapping the tips, so it makes the process a bit more difficult. Not the end of the world, it still comes out and goes in, but the JBC is buttery smooth, and this is not. Another thing I've noticed is that the lead of the handle is a bit shorter with the Bakon. That's my JBC, and yeah, it's not the end of the world, but it would have helped to have this extra 30 centimeters on the cable itself. And on the same subject, the mains lead is also pretty short, so it, again, not the end of the world, but it would have been nice to have an extra half a meter so you can reach a socket, basically, because you don't always have a socket very close to where you want your equipment. But besides that, the station has been working totally well. I'm really happy with it. Do I recommend it? Well, I would say yes, just bear in mind the stand limitation, but the station is working fine. I'm happy to recommend it. What about the price of the station? Especially after what I said about the stand, I guess the pricing is important. Currently, the station is being sold at $135 shipped. And Bakon offered me a $20 voucher that you can use on their website, and the link is down below in the description. So you'd end up paying $115, which are £85. I'd imagine you might need to add tax on that, but I'm not sure. I've also added a link to the official Bakon AliExpress store if you prefer that way, but the voucher won't work there. And at this price, I think this is actually a good station. Once again, it's not perfect, but the station as a soldering station, it works perfectly fine. Once again, bear in mind that JBC I've been comparing this to is about 5 times the price. These stations come with 12 months warranty, and Bakon have confirmed that if you need to replace the plug because the plug of your country is not available, that will not invalidate the warranty. So yes, I'm really happy with this station besides the stand, and this is definitely gonna live on a shelf here as my secondary soldering station. Why secondary? Why not using it as primary? Well, I paid 500 quid for my JBC. I'd like to keep it as primary if you allow me to do that. But honestly, I don't have any concerns about the Bakon. It's just a bit slower than the JBC to warm up, and the stand, everything I said about the stand. Before I close this video, a quick mention of the tips that you're gonna use. Remember that the tip quality will change your soldering experience. You can spend £1,000 on a soldering station, but if you then use crappy tips, well, your soldering experience is gonna be crap as well. Now, I cannot comment on the quality of Bakon tips. They sent me this little conical tip. It's very small. I don't like the conical tips in general, and this is too small for what I do. Chances are what they sell is quite good. I might find out in the future. For now, I've been using genuine JBC tips. I'm not saying that they are the only good tips available on the market. I'm just saying that a genuine JBC tip is about £30, which is, what is it, like $35. If you go on AliExpress and for $35 you buy 10 tips, well, maybe there's a reason for that. Just bear that in mind, the tip will make the difference. And finally, let me thank Bakon not only for sending me this station and another one that I would like to review as soon as I can, but also for being very professional and for listening to all my questions and for being keen in listening to my feedback. So that's it for today. I hope you enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and Patreon, the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very much understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, and that's also very much understandable, well, I hope you enjoyed the video. That's it for today, thank you for watching, hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.